Alright, so in this video, I'm going to be solving the equation 7 to the power of x is equal to 70. So before we start on our solution, let's notice that this is an exponential equation, and x is an exponent, which is the variable we're solving for. So let's just try to plug in a number. Let's start with 1. So we have 7 to the power of 1, and this is equal to 7. Now, let's go one higher. Let's go 7 to the power of 2. This is equal to 49. And now let's go one higher. Let's go 7 to the power of 3. This is equal to 349. So notice how we're trying to find what value of x that we should take the power of 7 to equal 70, but even the number 3 results in a number much higher than 70, meaning the value of x is going to be a decimal somewhere in between 2 and 3. So now to actually solve for x, my equation is 7 to the power of x is equal to 70. And what I'm first going to do, and what I recommend doing for any exponential equation such as this, is taking the log on both sides. And the reason you should do this is because now you can use the property log a to the power of b. I can move this b to the front, so I get b times log a. Log a to the power of b is equal to b times log a. And the reason this property is so useful is because before, x was an exponent, and it's really hard to solve for x in its previous state. But now I can move x to the front, and it's going to be an actual term. So now I get x times log 7 is equal to log 70. Now, log 70 is the same thing as log of 7 times 10. And another property of logarithms is that if I have something in form log a times b, this is equal to log a plus log b. So log of 7 times 10 is going to equal log of 7 plus log of 10. So now from here, what I'm going to do is divide both sides by log 7, because we obviously want to isolate x, so the only way to do that is to get rid of this log 7. So then these two cancel out, and I get x is equal to log 7 plus log 10 over log 7. And I can rewrite this as log 7 over log 7 plus log 10 over log 7. Now log 7 and log 7 cancel out, so I get x is equal to 1 plus log 10 over log 7. And if you guys already didn't know, log 10 is actually equal to 1. So now I get x is equal to 1 plus 1 over log 7. And this is my answer. Alright, so in this video, I'm going to be solving the problem 9 to the power of 900 minus 9 to the power of 901. So, to solve this, I'm going to first start by evaluating my terms. So we have 9 to the power of 900 and 9 to the power of 901. And these two terms are pretty similar, except that the exponent for 9 to the power of 900 is 1 less than the exponent for 9 to the power of 901. So the easiest way to solve this is to simplify this as much as we can. And a way to do that is to factor out a term. Well, 9 to the power of 900 is actually a factor of 9 to the power of 901. So all we have to do is rewrite 9 to the power of 901 as something times 9 to the power of 900? Well, we can use properties of exponents to do this. So I'm actually going to rewrite 9 to the power of 901 as 9 to the power of 900 plus 1. And now I can use the exponential property a to the power of m plus n is equal to a to the power of m times a to the power of n. So I get 9 to the power of 900 minus 9 to the power of 900 times 9 to the power of 1. So now from here, these two terms have the number 9 to the power of 900 in them. So I'm going to factor out 9 to the power of 900, which is what I said I was going to do at the beginning of the video. So now I get 9 to the power of 900 times 1 minus 9 to the power of 1. And this is equal to 9 to the power of 900 times 1 minus 9, because 9 to the power of 1 is the same thing as 9. Now 1 minus 9 is equal to negative 8, so I get 9 to the power of 900 times negative 8. Now from here, I said I was going to simplify this as much as possible, and we can't really get the exact value because 9 to the power of 900 is such a big number that we can't actually get the exact value for that. However, what we can get is the simplified value, and we're going to simplify it as much as possible. So I'm actually going to move this negative sign to the front, so I get negative 9 to the power of 900 times 8, and this gets me negative 3 squared to the power of 900 times 2 to the power of 3. We're simplifying these terms as much as possible. So I'm going to use a quick exponential property that states that a to the power of m to the power of n is equal to a to the power of m times n on 3 to the power of 2 to the power of 900. So I get negative 3 to the power of 1800 times 2 to the power of 3. So this is my final solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and even show this to any of your friends and family. That would support me a lot. I have a bunch of other videos similar to these on my channel, and if you're up for any challenges, I have a bunch of those, so please make sure to check them out. And thank you for watching. Bye.